Okay, class 9 students, we were solving the problem of free body diagram and connected body problem. We will continue our discussion on it, and very nice problem today we are trying to understand. So these are applications of laws of motion. Free body diagram problem. Connected body problem. Let us understand this question. This is the horizontal surface of the table. What happens? A pulley is suspended with the help of pulley. A body of a small or m mass is hanging. This is actually pulley A, and also at the same time other body of 2m mass is placed on the table. Here again other pulley is there, pulley B, which is connected with pulley A like this, and also another string is there. Now here what we have to find out, we have to find out the acceleration of the objects mass 2m and m, and also the tension in the string. We have to find out tension in the string. How to solve this type of question or on the basis of free body diagram, and we apply Newton's second law of motion. Here we can see if a tension in the string is T, that is acting in upward direction, and weight of the body mg will act in downward direction, this tension will be same. Here also tension T, and if this tension T is there, then in this string also there will be tension T. Now these two tension acting to pull this body, so they are tension 2T acting on this part of the string. Now what happens if this body is actually pulled towards right through length L? If this is pulled towards right by a length L, then these two strings will also slack by L and L length. So overall, because this is fixed here, so this 2L length, increase in length 2L will appear in this string only, and this body will move by distance 2L. So that means if this body is moving through L, then the smaller body is moving through 2L, and this condition will be true with acceleration also, because rate of change of displacement will be velocity and rate of change of velocity will be acceleration. So if there is acceleration A, then in this body there will be acceleration 2. Now we will write here equations to solve this question. First, let us draw a free body diagram of this 2m mass. m is actually pulled by 2t force, so to produce acceleration A. Hence we can say here the force 2t is equal to 2m into A. Now let us talk about this body. This body is moving by acceleration 2A, so mg is acting downward. And tension T is acting upward. So, using Newton's second law of motion, net acceleration, that is 2A, so m into 2A is coming, so downward force minus upward force, m into 2A. So here what we are doing, we can write this equation as equation 2. Now from 1 and 2 we can find the value of acceleration A. So 2t is equal to 2m into A. So what we are doing, multiplying this with equation 2, we are multiplying with 2, and then we are writing, and what we are writing, 2mg minus 2t is equal to 4ma, and we are using this equation also. Minus 2t plus 2t cancel. So it is here 2mg and then 6ma. So we can say mm cancel. So the value of A is how much coming? 2g by 6. So A, that means this body will move with acceleration A. And what will be the body? So the body having mass 2m will move with acceleration A, that is equal to g by 3, and body having mass m is moving with acceleration 2a, that is equal to 2g by 3. We can find the value of tension also. 2t is given to m into 2g by 3. So T is actually 2 mg by 3. This is the value of tension in the string. Now one more question is there, that what will be the reaction of this part on the pulley? That means what reaction force the clamp will apply on the pulley A. What reaction force clamp will apply on pulley A? Now see here, very important one. These two forces are acting. This is T force. This is also T. This, if the pulley is applying tension T through a string on the body also apply that force tension in opposite direction. So here on this pulley A, tension T applied by the body, and here also tension T. So two force is acting on the pulley. And this 2 is acting at 90 degree. So this resultant could be given with the help of parallelogram law of vector addition. So what we see, this 2 could be given with the help of parallelogram law of vector addition, and we can find out finally the value So here this T and T, two forces acting at 90 degree, so resultant could be given on the basis of parallelogram law of vector addition. T square a square plus b square plus 2ab cos 90. Cos 90 is 0. So here 2t square, or we can say root 2t. So this is the resultant force root 2t, where t is value we can put. So finally this is the resultant force which is acting on the pulley when pulley suspends the bodies. Then what we see, the same amount of force actually pulley will transfer to the clamp, and when pulley is transferring the force to clamp, then वीडियो बन रहा है ना, हैं? हैं? So when pulley is transferring that force to clamp, then clamp will give the same reaction force. So here in this case, this is the reaction force by the clamp, force of the clamp on the pulley. So this is overall what we are getting the answer. I am summing up what we have done actually. These two bodies are connected with each other, but we can see here the acceleration is not same. Acceleration is this, the body has acceleration twice of this body. Why this is the point? Because here strings are connected in different way. Strings are connected in different way. So that is the case here. So that we have to do, and for that matter first we should decide if this bigger body is pushed towards right. If bigger body is pushed towards right by length L, then we see that this L length will slack the strings of these two pulley system, L and L. If it is moving through L, so these two also will move through L. So L and L, because this length is here fixed, so this pulley will bring 2L and it will give this body 2L displacement. So if the L displacement causes 2L displacement, then we can say velocity V will be having double velocity, acceleration A will having double acceleration. This is the main point of this problem, and then we will apply Newton's second law of motion, free body diagram. In both cases, in both body we are applying free body diagram. and we are solving and getting the answer. That is very important. Okay students, for today we are stopping our discussion. Next day we will start another problem.